excitation, and this current is called as response. Okay, so excitation to the response should remain same. Okay, so we need to find out it. Okay, now let's try to construct the circuit diagram. So first we will connect the, this is called regulated power supply. So how to operate the regulated power supply is, first keep it in, so initially you have to keep the current knob in maximum positions and voltage knobs in minimum positions, and that is the initial positions of the regulated power supply, and just give the supply. As soon as you give the supply, it will directly indicate that voltage and currents are zero position. Okay, so now we'll try to give the connections. So connect the positive supply of the RPS to the positive terminal of the board. This is called input port or input voltage, and connect the negative terminal of the RPS to the negative terminal of the board. You see here, just I applied the voltage to the input port. So to this port I am applying the voltage, to this port I am going to find the current. Okay, so how to find the current is, so this is the 1 kilo ohm resistor. In this branch I require the current. Okay, I'm connecting the positive, the current is entering, I'm connecting to the ammeter, and the next wire the current is leaving to this wire, we have been connected to this point. So V1, this is called excitation, means input. This is called response, means current. We are going to find out it. So I already told how to operate the regulated power supply. Keep the current in maximum position and apply the voltage. So slowly if you turn the knob, the course, the voltage starts increasing, and we are going to give approximately 28, and then come for fine adjustment you will be getting it as a 30 volts. So you can see here approximately we applied 30 volts. Okay, so approximately 30 volts is the excitation, and the current we are going to find out. So this we have to perform the theoretical calculation. In the next video we will be having the theoretical calculations of the video. Now we will see how to write down the tabular column. So this is the tabular column of writing. So first we applied a voltage of 30 volts. So this is the voltage what we have been applied, and the current what we have been applied is, current what we have been obtained is 9 milliamperes. This is a milliampere ammeter, and automatically you have to write down the response current as 9 milliamperes. Theoretically it is 8.67, and now we are getting 9 milliamperes. So excitation to the response, this nothing but resistance is 3.3 kilo ohm. This bridge network is offering 3.3 kilo ohms resistor. Now we are changing the positions. How to change the positions? Initially keep the RPS in off condition. So I am removing the ammeter connection, and now I am exciting the output port. Connect the positive at the output port and connect the negative to the input port. So now we can see here we are exciting the output port and we are finding the response in the input port. Okay, so previously we find the current in this branch, now we will find the current in this branch. Okay, so in order to find the current I am connecting an ammeter at the positive terminal, and I am connecting an negative to the ammeter, and see here again I am giving the supply. As soon as I turn on the regulated power supply, the excitation what I am subjecting to output port, this is the output port, how much is applied is 30. Therefore the developed current is how much? 9 milliamperes. Write down the 9 milliamps. Therefore position 2 voltage applied is 30, the developed current is 9 milliamps. Therefore 30 by 9 is 3.3, and this milli will go up, which is nothing but the total resistance of this bridged T network is 3.3 kilo ohms. Okay, so this is the verification of reciprocity theorem, means the reciprocaling of voltage and current is nothing but V by I ratio should remain same. That is called reciprocaling of voltage source, and current through is called reciprocaling of the positions. If you reciprocal the positions also, the resistance offered by the network remains same. This is what the validation or practical validation of reciprocity theorem. For this we require a simple network. You can see the what is there inside the network. So you have just a interconnected network. So this is an series arm 820 ohm, this is a series arm 1 kilo ohm, this is a shunt arm 500 ohm. So internally it is connected with two terminal, and we are shorted here. So whenever the supply is live only, we are doing the experiment, there is no risk. Why? Because the operating voltage is too low, and maximum current it can be supplied by RPS is only 1 ampere. So this is how to find out excitation to the response. The resistance offered will remain same. So now we can validate the remaining experiments. So the theoretical calculations for this will be available in the card. You can watch the theoretical calculations also. Thank you for watching. We'll meet in the another practical demo video. Thank you for watching.